And of course, I'm doing everything in a single code page. And this is a demo use. It's pretty cool to be able to do everything in a single code page and actually get it working, though, right? You can keep it in your head. I'm a C programmer, so I've always wanted the ability to actually just see everything in the same code page instead of what's happening. I've been a C programmer from 20 years ago. So it's nice to be able to come back to that. One thing I didn't get to show you, my friends, is that there's yet another way to run these applications and to build them. You can use Groovy. How many of you have heard of Groovy? Or use it? Oh, yeah, I forgot. This is actually kind of a Groovy 10, isn't it? This was a few big consulting companies here. I just remembered. Right, so Groovy is awesome. I'm a fan. And so we have something called the Spring CLI, like so. You can tell because it says Spring. If you have a Mac, you can do brew install Spring Boot. Or you can do GVM install Spring Boot if you're using the Groovy version manager. And the other thing is I can actually open up, I can say touch hi.groovy, Atom hi.groovy, and there we go. I'll say add REST controller, class, greetings, REST controller, and I'll say def hi path variable, string name. Okay, return this, greeting, hello, name, add request mapping, tedious, but I'm getting there, name, there we are. So I have a REST controller that's going to respond to an endpoint, and that's it. So I go back to the command line, spring run, hi.groovy, and that's going to do what's called an abstract syntax tree transform, or an AST transform. It's going to look at the code. Remember, by the way, earlier that I set the environment variable for 8020. That's why I'm just now starting up here. But anyway, it's going to look at the code. Localhost 8020, right? Right. So it's going to look at the code before the code gets evaluated by the interpreter and then compiled. It's going to try and resolve the token that it finds in the source tree. In this case, it's going to see at request mapping and at REST controller, and it's going to see that we have an object, and it's going to give us a chance before the actual runtime gets invoked to help rewrite the code. In this case, it's going to see that request mapping is an annotation. It's a type that can be unambiguously resolved by following the transitive starter dependency graph and seeing if that type is there. And since it can be unambiguously resolved, it imports it for us. It also automatically adds a public static void main and does all that. So the nice thing about this is, for example, that I have now the same application. I have a REST API up and running like that. If you're not all that keen on deploying the Spring CLI into production, which is fair, I understand, Spring jar, hi.jar, hi.groovy, and then you can just do java-jar, hi.jar. And of course, same rules applies. If I want to say server, or even better, I'll say server port, and I'll say 8050, and I'll say application.yaml, cat application.yaml, is that right? That's probably wrong. Okay. PW, okay, CVD, and I'll say Java. I've got my directory here, CD desktop. I've got hi.jar and application.yaml, so that's this one here, we saw that. Java-jar, hi.jar, and you'll see that that's now listing on port 8050 to the gentleman who asked about using overrides. And I can deploy that now just as easily as I could deploy the Spring Boot app that I wrote in Java earlier, right? This is the Spring Boot app after all. So it's a very, very nice way to get stuff up and running. Today we're going to use Java exclusively, but it's worth bearing in mind that after I'm done with what we talk about today, you could have just written it in Groovy and it would have been like 3 lines, you know? But that would be a very short demo, so can't do that. Okay, there we go. Goodbye to all that. We've got this REST controller. I've rewritten the code a bit. I've trimmed out the hypermedia because it'll make it simpler for my demo later on. But otherwise, this remains the same. Okay. And what we're going to do is we're going to look at the wide world of microservices. How many of you have been paying attention to this new hotness called microservices? Okay, so it's not controversial to suggest that the world has changed in the last 10 to 15 years. The architecture demands of today look nothing like those of 15 years ago. why then, why are we building applications like we did 15 years ago? Why does anybody think an EJB is a good idea? You know, this is not, and has not been a good idea in more than a decade. We have today several different drivers for this new architecture, for this new approach to software. One is scale, right? This is the most obvious one to us as developers. One is scale. I have now an unprecedented opportunity. If I build an application and I deploy it on the Google Play Marketplace, which of course accommodates or represents something like 60 or 70% of the mobile smartphone market. If I deploy to the Apple App Store, again, I can build something today that, if it's good enough, will be seen and used by millions of people, or hundreds of millions of people in no time. That's unique. We didn't have this opportunity 10 years ago. There was no way to do that, period. The only way you could even hope to have that kind of opportunity is if your app had the name Apple or Microsoft or IBM or Google underneath it, right? Nowadays, this is different. You can build something completely stupid, brain dead. And if people like it, it goes huge. This is a new scale that we just didn't have before. We talk about capacity planning, and capacity planning is the dull-eyed youths in the room won't even know what that term means in the age of the cloud, but capacity planning was the bane of our existence. You have to build for the everyday case, but then if your app business was seasonal or driven by some sort of spike in traffic, you would have these weird outages. You just suffered it, or you built and accommodated for that one day a year event. Either way, you were losing money or was doing something wrong, right? You had to suffer somewhere. Now with the cloud, these things are ephemeral. You can go up and down, you can scale out as you need to. A lot of different organizations are also being, they're getting huge because of the fact that they build on top of these social platforms. So, like Facebook or Twitter or so on. I'm not really a Facebook user. I'm not cool like the kids today. But I did some research on the Facebook to see what it was all about. And there's this thing called Farmville. Have you guys tried this Farmville? Farmville, as I understand it, and again, YMMV, okay? Farmville, as I understand it, is a very, very highly available, highly scalable way to spam your friends, your family, and your loved ones ruthlessly and endlessly until such time as they hate you. Now, again, I set it up, right, and I tried it, and wow, can they spam your friends, your family, your loved ones ruthlessly and endlessly until such time as they hate you with incredible efficiency. You couldn't have done that 10 years ago. You could not have done it, right? So by virtue of the fact that they build on the social platform, by building on Facebook, they get access to a community. They can go viral stupid quick, right? That wasn't something we had the ability to do 10 years ago. So again, another opportunity. I don't have to tell most of you this, but it's very clear, it's abundantly clear that, if you're some guy in your underwear in home, or girl, but in this particular case I'm speaking about the Flappy Bird guy. If you're some guy in Vietnam in your underwear building an app for 2 weeks, you can build something that changes the world. People killed themselves for that game. Literally took their own lives, right? That was some guy in his underwear. Hit crazy scale. Imagine if you had to build an app that had to accommodate that. So scale is first and foremost. When we think about microservices, a lot of us reach for scale, okay? And it's no wonder why, because any of us could have these problems tomorrow. It's not just the big web giants that have these problems now, right? You can't afford to build an application without scale in mind. Sure, some of us will just build an internet app that will only serve 50 customers. That's fine. But hopefully that's not the game, right? The other reason a lot of us are moving into this architecture is for agility. And again, I talked about agility earlier, but we're really keen on this, right? By decoupling your services, by breaking your giant, fat, web scale application, what we call a monolith, into smaller, singularly focused services, you can now, in keeping with Conway's law, which dictates that software will reflect the organizational structure that it serves, evolve those pieces faster, right? So think about Amazon. Amazon's a huge business with lots of different business verticals. They serve different use cases and goals. They have different executive leadership for each business vertical. It's not one Amazon.war. It's hundreds, dozens, thousands, who knows, services deployed across a giant data center. They created AWS for themselves, right? This is a scale problem, but it's an agility problem as well. And you don't solve it with WebSphere, right? You don't. I'm just asking ask Amazon how much they love WebSphere. They're not even, it's not even a thing, right? So Netflix is the same thing. Netflix has different pieces of functionality that, each project is what they famously call a 2 pizza box team, right? It's small enough that the operations, the leadership, the developers, all of that lives in the same team, and they can evolve their piece as they need to go. So, everyone clear on that? Conceptually, why we care about microservices? I think it's all redundant. I'm pretty sure I just wasted time. I hope I did, but sometimes you never know. Okay, so we're going to stand up a bunch of services using Spring Cloud. Spring Cloud is a toolkit that is built on top of the Spring Boot, and it commoditizes a lot of great OSS stuff for building microservices, not the least of which, of course, is the amazing Netflix OSS stack. We also have support for things like Contool and Zookeeper and single sign-on approach with Spring Security OAuth and so on. But we're just gonna go with what we know. Okay, so good. We've got a single REST API now already. We want to stand up we want to take care of a few other concerns. When you start to build a microservice architecture, let me create a workspace. Live. Okay, that's where we're going to keep all the code. Goodbye to you. What do we got here? Goodbye to that. Demo. This is going to be called reservations. Okay. There's this. Goodbye to that. Let's build out. We have a couple of things that are cross-cutting concerns that all of our different services are going to need, and you don't want to really waste time, getting them right each time. So we've already got a REST API. That REST API, again, in a real system, in a production system, in an actual system, you can have more than one REST API. One hopes. Otherwise, you're just introducing a lot of pain for no gain. But one thing we're going to want to solve up front is configuration, right? So configuration is when I talk about configuration, we talk about application properties and application YAML. I'm speaking specifically of something called 12-factor app style configuration. How many of you have ever read the amazing 12-factor app manifesto from Heroku? Oh, it's good. 12factor.net. It's great. It's a set of principles for building applications that breathe natively. They breathe naturally on the web. They breathe on the cloud. They can scale. They can be moved around. They're ephemeral. They can live as services, etc. natively, right? And in that world, configuration, not the wiring of your objects and so on, but instead database locator credentials and passwords and all that, these things live external to your application. You don't want that compiled in your jar. You want to do it as we did before with -G arguments or property file or whatever. So that if I move one environment, I can move from development to Q&A to production, one build, and not recompile for each environment, right? Very, very natural, but again, that's certainly a step forward. But if you think about that approach, it falls apart when you have a lot of different services. One limitation, of course, is what happens if I have a property that I want to change in 10 different places, some sort of configuration value that I want to change in different organizations, or if I want to introduce what Netflix describes as feature flags, right? Things that change for just a small set of users dynamically. It's going to be proved problematic, right? In the approach that we've seen so far, you have to restart the Java process each time to get the new configuration. Secondly, what if I have security? Security is something that it's not something you want to, this is not one place where you want to reinvent the wheel, certainly, and it's certainly one thing where you want to get it right for everything as opposed to getting it right for each app in its different way. If I want to have configuration, I don't want that living on if I've got passwords and all that, I don't want that living in my file system unencrypted. I want to be able to encrypt it and then in process, in memory, in flight, decrypt it using a key, right? And that's a recipe that I want to get right once and then never worry about it again. So we have a lot of different problems here. To solve that, we're going to use the Spring Cloud config server, okay? The config server is a piece of middleware. It's a little Java process that you're going to stand up. It's a Spring Boot app. Remember, all these are Spring Boot apps. But it's going to act as a proxy to a Git-based repository for configuration, okay? We want, after all, another benefit that we want for this is to be able to journal and trace configuration changes. Well, it turns out that Git is really, really good at tracing and journaling and rolling back changes, right? So we're going to use Git. I'm going to go to my initializer here, choose Java 1.8 because I'm awesome. I'm going to choose the config server here under the cloud column. No, too big, right there. This is where we're going to live for this talk, is mostly in this column, okay? So I'm going to choose the config server. I'm going to hit generate. I'll take some coffee. Coffee's good. Okay. And here we go. Command D, live, config, unzip, config, open that up. Ow. This is the slowest part of my talk, is waiting for the editors to open up. I think you might have a multi-module build maybe in a real thing, but, And by the way, what I just did is the long way around. Again, remember what we just saw with Groovy. So this is, all I'm trying to do is to build a config server, right? So in order to do that, I say @enable config server, and that's it. But literally, if I want to do it with Groovy, well, it looks like what you'd expect it to look like. It looks like, class X, right? That's it. That's the same thing. It'll do the same trick. So you can do this, or you can write the Java code, and all I've done is code generated. So it really didn't. It cost me this annotation. So it was a lot of work either way. So okay, I need to point this to a repository. I'm going to point it to a Git thing, an index, right? And then everything else is going to talk to this server. So I'm going to point this to Git, but everything else is going to talk to this running process, and they're going to get their configuration live from this running Java process, which is going to act as an intermediary, a proxy. So I'm going to say spring.cloud.server.git.uri equals home /desktop / I don't know, where did I put it? Desktop CD workshop maybe. So I'm going to copy my config repo to the desktop /live, and I'll go to the desktop live, my config repo, pwd, pv copy, nope, fail, and it's going to be here. So there we are. So that's where my configuration is going to live, right? This is just a Git repository. I've got a few different property files in there. Each service, all services will get the property values in application.properties. That's the fallback. It'll get loaded first, but then specific to each service, for example, the Eureka service or the reservation service, which we already defined earlier, I'll get the overrides here. So if I have something that conflicts between this and this will always win. Okay. But if I have something I want common to all of them, I can put them here. So that's very convenient. And you can also specify that I want profiles. I can say reservation-service-dev, for example. So I can activate configuration based on which environment I have the application in, and so on. Okay, I need that. Good. Application. And then I need to do, what else do I need? I want to say that the port is 8888, okay? And then a Spring Cloudism, instead of having application.properties, for most of the code that we're going to create today, we're going to use bootstrap.properties, which is read before application.properties, and it's used, for example, to point other services to, for example, Spring Cloud config server, where it can read the properties it needs. Right? So it has to necessarily happen before everything else. So the one thing we're going to do is specify spring.application.name equals config service, and then we're off. So let's run this. Okay. You can do it. I was hoping that they would, not that they could, but I was hoping that they would do a Spring Cloud ASCII artwork thing, but cowards. Okay, so that's up. Here we go, localhost 8888. And then what is our config? What's a service that we want to look at? We have live, my config repo. Okay, we want to look at Eureka service. Okay, so if I go to Eureka-service master, you can see there's configuration in there. This is a JSON representation of the configuration as it's resolved. If the Eureka service were to connect to the server right now and ask for its configuration, it would get the property sources from this file here and the property from there, right? So what I've done is in application.properties, I said server.port is 0, which means that it's going to be randomly picked by default, unless I specify a specific one here, right? So 0 means find the first unused port, which is great for things where I'm standing up lots of services and I need to test, okay? Otherwise, I'm not doing all that much interesting. I'm telling Eureka that it, well, we'll come back to that, but it's basically telling Eureka not to register itself with Eureka. Okay, good. So that's working. We need now a service registry. Now, when we talk about service registries, it's a broad class of technologies. There's things like FTP, there's Consul from HashiCorp, there's Apache Zookeeper, which is phenomenal as well. There's Netflix's own Eureka. For our purposes, it's easy to think about them as a phone book for your services, right? It's a directory, it's an enumeration of all the existing services. It's a brain of the system itself. It knows where everything lives. And the reason you want that is because you want to decouple the availability and usability of a service from its host and port, right? And you want to be able to ask questions about the service. Is that service available? If so, where? Otherwise, do something different, right? So you can ask that question from a service registry. So we're going to use Eureka in this case. We're going to also make it a config client. We'll come back to that. So we're going to say Eureka server, and I think that's it. So I'm going to hit generate. Show and finder. And Eureka. Okay, Eureka. Open that one up as well. There's two different ways to consume this, of course. There's an API. There's also a WebWare dashboard for fleshy human thingies. So I'm going to say Spring Cloud Config Client. I want to act as a client to the configuration server. So I'm going to get my configuration from the config server. I need to tell this application where that configuration lives. And again, that's one of those things you want to naturally put in bootstrap.properties. So I'll do that in a second. I'm going to say spring.application name equals Eureka service. I want to say spring.cloud.config URI equals HTTP localhost colon 8888. And again, I'm pointing it to the config server so it can resolve that, and everything else will be resolved via that service. However, it's much more natural to say, config server, then do that. So I'm saying resolve it by an environment variable, and if the environment variable isn't available, then use this literal. That's what that syntax means. That's much more useful in a real system. But for our purposes, let's just keep it simple. Okay, there we go. So I'm going to move all this into bootstrap.properties, like so. And that's going to be the gist of most of what we're going to do for configuration for each of these services, like that. Get out of this. And I'm going to stand up a Eureka instance. I'm going to say @enable Eureka server. Great. And the Eureka service is going to get the configuration from here, as we saw earlier. It's going to live on port 8761. It's going to have access to this message. And just to prove that everything's working, we'll do this. We'll say @value message. Okay. String message. Actually, I'll do void set message. String m. Do I want to do it? No, I'll do it the other way. Here. String message and lazy. So I'll do this at home. I'll say request mapping message. I'll say string message, whatever. Return this message. I'm going to create a class, REST controller, public static class message, REST controller. Just trying to prove that I can inject this value and make it available. It's probably not the right place to put it, but whatever. And because I want to be able to reread that value later, I'll also make this being refreshable. Okay, so refresh scope. And there we go. That's a simple REST controller that'll do just one thing. It'll return the contents of this config property. And otherwise, this is a Eureka. You wouldn't normally have this here, but I'm trying to do a demo, so here we go. Run. And we should be able to go to /message and see the message. And then we'll go visit the Eureka service registry as well. Knock on wood. Okay. Localhost 8761. Message. There's that, right? I've got it in here, and I may want to change it. This is a nonsensically trivial example, but I may want to change it. Imagine instead that I had created a data source bean. Oh, by the way, that is Eureka upset that I have not configured it to be highly available. See, it says, is replica available? You get really, really, really unhappy when you do this, because it is the nervous center of your application. It cannot go down. Everything else is going to talk to it to figure out where everything lives. So you need to set it up in a highly available fashion. That's dead simple to do, but for want of time and lazy, I'm not going to do that. Okay. So okay, I have a configuration value here. I may, for example, have defined a data source like this, and I can say, Oracle, whatever, whatever, and I can say at value, ds.url, right, or password or whatever. If I define a bean, I can inject configuration. That configuration comes from the config server, and I may want to refresh that configuration later on. So I've got this configuration value in my Git repository. Here, I'm going to say hello Chicago instead. I'm going to go to the command line, pwd, live my config repo, okay, git status, okay, git commit, changed property, great. If I go to the config server itself, you'll see that that is reflected immediately, right? So hello Chicago is there. But my REST endpoint will not be updated. I need to trigger that change by hitting the actuator endpoint called refresh. Okay, so curl -d, curly bracket, localhost, 8888 / refresh, or sorry, 8761. Voila, okay? And what that's going to do is it's going to tell that single instance to refresh itself and recreate that one bean in situ without restarting the application. I can connect this to a bus based on RabbitMQ using the Spring Cloud event bus. And then every node connected to that bus, when it gets this, instead of triggering /refresh, you go to /bus /refresh on one node. It'll publish an update message to every other node, and it'll trigger a refresh of the configuration of the beans in situ everywhere. Remember, what I'm doing here is I'm recreating that bean dynamically. This is what this is doing. It's throwing away the old controller and creating a new one. So in theory, if you manage to update the Java bytecode in between refreshes, that would also be visible. But that's not what we're trying to do here. We're just trying to change the configuration and reevaluate that. Okay, so that's not what I want. That's not really the interesting thing. Let's talk about Eureka. Here's Eureka. At the moment, there's nothing registered, right? There's a REST API for this as well, but this is what we're going to look at because it's easy to visualize. We want to register our apps and find them through that endpoint. So when did I just killed it. Son of a gun. Okay, Eureka up and running. Go, go, go. Faster, faster, faster. Fat fingered it. Didn't mean to do that. And then this is my config server. Good, that's up and running. We need, let's see, reservations. Where's the reservations? There's Eureka, config. Okay. Let's open the reservations one up. Open. Desktop, live, reservations, pom.xml. Lead existing project and import, view window. So this is the reservations one that we just worked on so tediously over the last hour. I'm going to bring it into the fold here. First it needs to know about the, okay, thank you. It needs to know about the Spring Cloud dependencies. So in order to do that, I'm going to bring in the special dependency management section. And it has import type is POM and it's scoped for import. And all that's going to do is it's going to bring in all the Spring Cloud starters, just like Spring Boot already does for us. Okay, so there's this. And once I have that there, I can now go to my build and I can say bring in Spring Cloud config client. And great, okay. And I need also Spring Cloud starter Eureka, so I can get it to participate with service registration. But again, it could have been Spring Cloud starter Zookeeper or Console or Cloud Foundry, which already knows about your services as well. So that's the implementation. It's a common abstraction across all these different implementations. And because this is a Spring Cloud microservice, I'm going to add a, we don't really need all that, in fact. We can leave it if we want, but we don't need it. So I'll get by. I'll keep this here though, bootstrap.properties. Okay, I'm going to copy bootstrap.properties. Oh, other one, I need one. Bootstrap.properties, okay, look at that, paste, and it's going to be reservation service, otherwise it's the same, okay? I'm just teaching it where the config server lives. By default, it's going to know where to look for Eureka, but you can specify that as a property as well. And we're off. So let's run this. The other thing I need is to say, you should be aware of service discovery. So @enable discovery client. There are specific, I could instead do @enable Eureka client, right? But that is just a meta annotation for @enable discovery client, which is what you really want. So So, you know, just it's a specific way of decoupling. Good. So run, run, run. Here we go. Run. And that's going to tell this Spring Boot app that it should discover and register with Eureka under the name reservation service. And in a couple seconds, or 30 seconds actually, to be accurate, it'll register there. Whoa. Come on. Waiting for it. That's the Eureka thing. That's the replica bits. I'm not expecting that to be too much trouble. There we are. So now refresh, there's reservation service. And if you, I don't know that you can see it in my code here, but on the bottom left corner there's a host and port on the browser. So I can actually visit the one instance that is available now. If there are 10 instances, they'd all be registered here as well. And there's an API, so I can say, find all the instances of reservation service and tell me where to live, whether, you know, and so on. You can even do things like capability querying. You can actually put in metadata to each one of these instances, but that's a more advanced feature here. Okay, so this is 8,000, this is reservations, right? That's my service. I've got Eureka, it's working. I've got config server, that's working. Let's build a client that consumes a reservation service, okay? And here's where we're gonna see a lot of the power. So start.spring.io. I'm gonna build another Spring application, and I'm gonna act as a client to Eureka, great. I'm gonna act as a client to config server, we'll come back to that. We're gonna support the circuit breaker for mitigating shaky service-to-service calls, cordoning them off, so to speak. We're going to use Zool for micro-proxies. We're going to use Ribbon for software-defined load balancing. And that's, I think, not enough. We also want declarative REST clients with Fame, so we're going to bring that in as well. Okay, so don't worry. We'll revisit all this in a second. Hit generate, and that'll be demo parentheses 3. Okay, and we're going to go to live, paste, client. Okay. Client, and we're going to build some code. Now this is where I have to go fast. How much time do we have? Somebody tell me like an hour.
2 minutes.
How many?
13.
Awkward. Okay. This may be just a minute or two longer. Okay. Dependency, Spring Cloud Config Client, because we need that naturally. This is, just as the other ones are, a microservice, and it needs to be, it's going to play a part with, it's going to be a part of the ensemble, so we'll say bootstrap.properties, great. And we're going to go over here and copy all that, because why not? Reservation of client, sure. Otherwise, it's the same. And we're going to build some code. So the first thing I want to do is demonstrate the discovery client, right? So the discovery client is the abstraction I was telling you about that lets me talk to Eureka in a common way, right? So I'm going to build a bean of type command line runner, DC. I'm going to inject my Spring Cloud Commons discovery client reference. Again, there are numerous specific implementations depending on the types you have in the class path. I'll say args, and I'll say DC.get instances of reservation service. You need to type for this to work. Reservation, that one. Just make sure I don't fat finger it for no reason. Okay, here we go. Edit. Anybody here see the right thing? Toggle case, naturally. Oh. And then for each instance, all the instances I get back, I'm going to do for each, and I have service instance objects, so for each service instance, I'm going to say si.get host, si.get port, and that's it. I'm just printing out the information about each service instance I get back. In this case, we'll see, ta-da, surprise, that I've got one instance registered for that service. Okay. So let's see if that works. We can run that one already. That should be a start. Come on. Good. So we see that it's running on port on my host, which is JL, and it's running on port 8000. Works. Great so far, right? That's a little low level. However, if you think about it, all that's going to give you what's going to happen is I still have to pick from all the available instances. If there are 10 of them, for example, I have to pick the right one, which, who does that? And then I have to actually plug in those hosts and ports and all that stuff into something more meaningful. I'm not in the business of just loading hosts and ports. I want to make a call, after all. So those are two different concerns. Load balancing is something that we believe in the microservice world should be handled on the client. Right? The client is in a better position to make the decision about which service to call than some big 5 router configuration. Right? In mid-tier services, we're not talking about stuff that your front-end clients are going to talk to. I'm talking about all the services behind the edge, behind the firewall. And so you want to be able to plug in your own custom load balancing risk name. This is something that Ribbon supports, right? We plug in Ribbon for you, and it already knows about the Eureka registry or Cloud Foundry or Lattice or Zookeeper or Console. And you can use it in several different places. The most natural place, I think, for a lot of people is to make a REST call, right? And Spring already has a client called the REST template, which makes it dead simple, makes it a one-liner to call other services using REST. So we're going to just use the blessed sort of magic REST template that gets automatically configured for you here. And it is already Eureka and Ribbon aware. Now again, we can plug in custom algorithms, but by default we'll get round-robin load balancing. For all the configured service instances that are Eureka, it'll just pick one based on randomness. You can plug in your own though, right? This is very useful. For example, if you want to do sticky, you have sticky state or something, or maybe you want to do availability zone aware load balancing, or Amazon data center zone, whatever, right? Whatever your use case is. Maybe you have multi-tenancy and it's just only these servers handle customers A through B or whatever, and then those handle B through C. Whatever that is, that's something you would plug in into Ribbon. Okay. So I'm going to use, I'm going to build another command line runner, and I'm going to use the REST template to make a call. I'm going to say call HTTP reservation -service. I'm not plugging in a hosted port here. This is just the service as it's discoverable through Eureka. And actually, I'm going to call exchange. Okay, and I'm going to say exchange, passing in the HTTP method.get, and I'm not going to bother with request entity, and I'm going to return. I'm going to use a parameterized type reference. Okay, and that's a PTR. And that thing looks like this: parameterized type reference of list of reservation. Now, what we want is I want to be able to have entities that come back from the REST service, and I want them to be coerced into a list of reservation objects. And this is not the same reservations that I have in my JPA service. This is another type that I have in the client. You could, of course, pass around the same types, but why? That's very, you're polluting your namespaces here. That service may have been implemented in some other technology besides Java and Spring, and that is, loath I am though to admit it, one of the possibilities, and indeed one of the virtues of the microservice architecture is now I can build the service using the best back-end technology for the job. If I have a team that is just super comfortable with .NET or something, and they build that service that way, great. Who cares? Do that. It's just REST for all of us who care, So I'm going to pass in a parameterized type reference, and I'm going to tell it to coerce the response that it gets back from the JSON into a list of objects with an ID and a reservation names field, okay, like this, just like the entity that we have on the actual code there. The parameterized type reference is kind of a hack. This is something that we have to do in Java because Java doesn't understand generics. It doesn't generic well, right? So what's happening is Java doesn't bake in the generic type argument in instance variables. At runtime, there's no way to ask PTR what its generic type parameter is if it's just a new instance. Only for subclasses can I do that. So this is an implementation of the type token pattern, which is a hack that was proffered by the likes of Josh Block and so on. And so there's an easy way to get around it. You have to create an anonymous subclass. That's what I'm doing here. This subclass, this PTR, is actually not a parameterized type reference. It's an anonymous subclass of type reference. And that way, at runtime, I can ask it, what is your generic argument type? It's a list of reservation. And I can give that to my REST template call here, which can then use that to extract the fact that I'm getting a list of reservations back. And I say list of reservation, like that. Okay? That get body. Now I can go through each one, and I can say reservations for each, and I can say system for each R sout toString builder reflection toString R. Oh, this is concise. Okay. Okay, so I'm just going through each one and I'm printing out and I get back to the JSON output, and I'm using this reflection thing to make a pretty two-string. Okay, nothing fancy. So that one should work, and indeed what's going to happen is it's going to see that reservation service identifier, pass it to Eureka, it's going to get all the service instances back, and then it's going to plug it into Ribbon, which is going to do the load balancing, and then it'll give us the first available instance, and then all behind the scenes it'll replace it with a hosting port for us. So now we're able to just write code and not worry about where the thing lives. So let's run it again. Go, go, go. Yeah? Any questions? No? Awkward. What happened? What just happened? .404 not found. Reservations. Nuts. So this is a middle ground between type-safe objects and HTTP and strings, right? This works. I still get the benefit of pretending I have types here, right? I can do that pretty naturally. But I am still dealing with REST input, so I can actually modify status codes and set up authentication and do all that stuff very naturally. And of course it works, right? There's our data. That worked as we expected. We got what we wanted. But, you know, taking it a step further, I may want to move even a step beyond that. So instead I'll use something called feigned. Feigned is a way of declaratively building REST clients using interfaces in the same way that we use Spring Data to build a repository based on convention and interfaces. So I'm going to say reservations REST client. I'm going to say @feigned client. And I'll say reservation service, and this is again Ribbon and Eureka aware. I created an endpoint here called reservation. Get reservations. And I'm going to annotate it with request mapping from Spring MVC, which is a little weird because this is the client-side mapping here, right? And it has to be value equals, and I have to say that it's a method equals request method dot get. Okay. And again, if I had a path variable, if I had a parameter that I need to pass in, I could say path variable, you know, ID, for example, and then that could be like this. But I don't in this case, so I'm not gonna. Okay. So you understand? Good. So now, anywhere in my code, I can inject this REST client and make a call using a sort of high-level type now. So I'm going to say bean command line runner DC. No, I want feign, right? Feign. So it's going to be reservation REST client. Good. That's the right one. Return args. And I'll say client dot get reservations, and then of course for each one I get back, I'll say system. System. What did I want to do? Oh yeah, R sound two-string builder dot reflection R two-string builder multi-line style blah blah blah. Okay, so same as before. I'm just printing everything that I get back out. This is doing what? Oh, the ID is useless in this case. Okay, there we go. So now we rerun that again, and we should see now two enumerations of all the services, of all the reservations in this case. There we go. 1, 2, 3, 4, 5, 6, and the discovery client one, and then 1, 2, 3, 4, 5, 6. So now I've gotten progressively more abstract, progressively more high level and type safe. So again, yes, we're introducing lots of services, but you don't pay the cost. You have these very nice tools to work with, consume, and manipulate services. You know, and at whatever gradient you want, right? This is just as a client. This is all we've talked about here. It's very common to have edge services that talk to backend services, these mid-tier services. And the reason you want to do this, as for example, as Netflix does, is because you want to adapt the requests that the client are making, or clients are making, to the backend mid-tier services. Netflix famously has something like 600 different microservices, each of which does its own thing in a different way. It'd be insane if they had to retrofit every one of those microservices whenever they added a new client, a new PlayStation or an Xbox or iPad or whatever. So instead, they set up an edge service, something like, you know, sometimes it can be as simple as something like Zool, right? So Zool is a micro proxy. It's a way of forwarding requests from the client all the way to the backend services. We can use that as well. So we're going to do that. We're going to say @enable Zool. Okay, @enable Zool proxy. And if we run this, there we go. it'll automatically expose everything it finds in Eureka for us. So if I go here, this is running on which port now here? I don't know. Might have to wait for it to register itself. Port, please. Anybody ever seen a port? I came from port. Ah, there we go. Okay. Local host. And now I can say reservation, service, reservations. And then I'll forward using reactive IO. Say, it's evented IO, it's using RxJava. It'll forward the request to the backend into your service. So if I have another service, I can get at it from, if it's called food service or reservation service, whatever, that may be all I need. If I'm using an HTML5 client and I just want to talk to these backend services and I don't want to worry about running afoul of class origin request scripting policies, great, I win, I'm already done. So they stand up an edge service like that for every client. So instead of retrofitting these backend into your services, they leave that alone and they set up an edge service. That's what the client's connected. And that you'll stick behind DNS instead of Eureka. That will be highly available. That'll be something you load balance using the cloud extensively, that kind of thing, right? A lot of times, though, maybe they don't want the direct access to the backend services. Maybe they want to aggregate, transform, adapt, whatever, right? So that's another thing we should look at. So I'm going to create a REST controller here that adapts the backend service here in this case. So it's REST, reservation, names. This is a straw man, okay? REST controller. I'm going to create a client that does my integration code for me. I'll create a reservation integration, and it's a regular component. And in this code, I'll say @autowired. I'm going to inject my fame client here, so reservations REST client. And all I'm going to do is expose an endpoint. I'm sorry. I'm going to return a method that returns the names. Actually, I'm just going to return the data, I guess, so that'll be fine. So, the names of the reservations, not the actual objects themselves. So string get reservation names. Thank you. And what I'm going to do is I'm going to call the reservation REST client. I'm going to say reservation REST client get reservations, great. And I'm going to say stream, which is a Java 8ism. And then for each record that I get, for each R, I'll call r.getName, reservation name. And I'll call collect, and I'll call collectors.toList, and return that. And so what I'm going to get is a collection that has strings in them instead of the actual objects. I'm just transforming each one and creating a new, object. And this is kind of useless transformation, but it does demonstrate the point. What happens if the service is down? This is going to blow chunks, right? It's going to throw an exception and something is going to go wrong. If there's no instances of that service available, I want to make sure that if something goes wrong, I have something graceful. I have a graceful degradation, right? So we can use the circuit breaker pattern to cordon off shaky behavior. So instead, I'm going to say get reservation names fallback. I'm going to create another method here. It looks exactly the same, except it's going to be named this. And all that's going to do is return collections.empty list. And if something goes wrong inside of here, it throws an exception, it'll call this instead. So we have the ability to gracefully degrade, right? You see this all the time. If Netflix's search engine is down, maybe they'll show you recommendations instead, right? But they don't just stop working. There's a great talk by a microservices by a gentleman named Fred George out of the UK. He describes the human body is a microservice system, and I love the way he thinks about it. He says that it'd be awful if when you pricked your finger, you just blue screened, right? Like, that would be the worst. You need to gracefully degrade. So yes, your hand may have been cut, but the rest of you continues to function, right? Same for your service system. So here, we're going to have a fallback, pretty mundane. I'm doing nothing useful here, but you get the point, okay? So reservation integration, and then that I'm going to use inside of here. I'm going to say request mapping /rs collection of string reservations. I don't know, whatever, who cares? And I'll do @autowired private integration, and all I'm doing is forwarding my call to that integration code, which is potentially going to fall down, and we'll see So good, that's up and running. Now I can restart. And again, I may do adapting and transforming, something more interesting. In fact, if I have multiple calls, I may have an aggregate that I return that is a combination of two different services. And I would do that here, right? And that's a great use case for reactive IO, like RxJava. So you can make calls concurrently and then join them back together very, very naturally instead of, tinkering with threading primitives and semaphores and all that stuff. Just do it with RxJava. It's much, much more concise. Okay, so here's the different hosted port. Love that. Where are we? I think it registered itself either way. Good. There's the client. It's on port 58281. I would have found that eventually. So there's my list of names, right? And it's clearly working. I'm calling the backend service, but I'm not, I'm just getting the adapted the payload here. What happens if I take my my reservation service out of the game? So this is the reservation service. I'm going to go here, and I'm going to exit the code. Okay. Goodbye, and I go to Eureka, refresh. It's instantly gone. Now when I go to my code over here, it's going to make the request, and nothing works. I did fallback gracefully now, right? And if I bring Eureka back, if I bring reservations back, like so, that will come back into life. Now, in the meantime, I want to see where these shaky circuits are. I want to see what's happening. I want to visualize what's happening. So, one last thing. Do we have time?
It's lunchtime.
How much?
It's lunchtime now.
Okay. Well, do you guys mind for like another 5 minutes?
No problem.
Are we okay? Or okay.
I'm hungry.
Me too. For knowledge. So, district dashboard. Click on that. Good. Choose Java 1.8, even though it doesn't bias anything in this case. Good. Hit generate. Show in Finder. Command live. Districts dashboard. Okay. Districts dashboard. Open that up. And same as before, it's going to be a client to everything else. Okay, so source, main, resources, bootstrap.properties. Almost there. Paste. And I'm going to go to my public static void main at enable districts dashboard. Great. I have the config client on this. If I needed it, I don't in this case. It's just consistency that matters here. Great. Okay. And I want the registry as well, so dependency, Spring Cloud, Starter, Eureka. Okay. Enable that. Do this. Okay, voila. Run. Oh, awkward. Oh, wrong port. So, what's the wrong port? Oh, it's the reservation service of the dashboard. Districts dashboard. Okay. Okay, up and running on which port? Everybody knows. 58360. Localhost districts.html. And by the way, this reservation service is now back here. So if I go to the dashboard, so I have this dashboard now. And what I want to do is I want to point it to the stream of service and events that are coming from my circuit break, all the code that has circuit breakers in it, the Hystrix command annotation. And I want to visualize what's happening. So in our case, we've only got one service that's doing this. That's the reservation client. That's this one right here. So I'm going to say, go to that one, /Hystrix .stream. Oops. Like that. Okay. Nope, not like that. Hystrix. There you go. And monitor. And what that's going to do is it's going to show me information about the services, about the clients, right? So about the circuits. So if I go back to here, where I have that shaky circuit, hit refresh, you can see as I lay down the gas on the left window, it's giving me a moving average of traffic on the right, right? And so you can see as I throttle the gas that it's draining off and traffic is diminishing. if I open the circuit by by shutting down reservations again, exit, and then I go back here, refresh, you can see now it's red immediately. All right? So I can see that there's something wrong. I might have to intervene, something is in trouble, whatever. This is just one service. If I have 100 services, each of which has different circuit breakers, I can aggregate that using something called Turbine, which is another checkbox on startup.spring.io. So I get one dashboard for all of this. Well, my friends, I think we haven't really covered a lot, but we're going to have to stop here. This has been a look at how to build resilient services. We've only had one service in this case. It's not much of an architecture, but the idea is that you have lots of these little things running around. You can see that most of the stuff, the Histrix dashboard, the config server, the Eureka, these are infrastructure things. You don't have to write this every time. You'll get it right once, operate, and then reuse. In point of fact, instead of writing it in Java, just write it as a one-line Java, Groovy script, and then use -d arguments to override the things I had to use to config stuff. And then you don't even have to do that again. Just create jars and then you're done, right? So as you build microservice ensembles, you'll start to think about these things in terms of distributed systems, right? And all distributed systems have cross-cutting concerns, but you can see with the tools that we have here, we can really build that fast if you have the right tools. We haven't looked at messaging, right? So if you talk about state synchronization between services, messaging is a very natural way to go. You can get some of that by using using reactive.io. That's why we talk a lot about Rx Java as a way of consuming different REST services. CQRS is sort of a natural next step as well, right? If we have different bounded context views on data and you want to have a sort of an aggregate model of all that state, messaging again through CQRS is sort of natural. And you can talk about single sign-on using security. So again, with Spring Security, with Spring Cloud Security, you get the ability to stand up an OAuth identity provider, an authorization server, and then protect every connected resource, every REST API, say enable REST resource or OAuth resource. And you can say you need to talk to this authorization server to get a token. Otherwise, it won't let any requests go through. And that integration for single sign-on it goes all the way through to Zool, for example. So if you make a call to Zool, it'll proxy the requests to back and so on. So we didn't get to talk about a lot here, really. But it's a start. What do you think? So far? Okay?
Awesome.
Worth your time? Okay. Thank you so much, guys.